Hi, welcome back. Now, when I last left you, I had this right here, this negative exponent. I was explaining why I thought that any number to the zero power was 1. And then I continued this pattern into the negative numbers and left with, well, what's going on with this negative exponent? How would you express that? Well, I think that what I'll do is I'll continue with my thought about this. I'll erase this top part here. Let's see. Erase this here and use this extra space to expand this up. And well, let's continue. If this were 3 5s being multiplied, and that's 2, and that's 1, and that's 0, which is why I said that's 1. Well, what's going on with the negative? Well, we could still have the 1 here. 1. But now, since the opposite of positive is negative, we need to use then the opposite operation. Instead of multiplication by 5, the negative would tell us we're dividing by 5. And so this would be 1 divided by 5. See, now the 1 is quite important here, as it's more than just this trivial little, oh, I'll just multiply by 1. This now fully explains the relationship between positive and negative as opposites, right? And then also here expressing as opposite operations. And 1 divided by 5, well, we usually write that as 1/5. And so if I have 5 to the negative second power, that is still our 1 here. And instead of this being 5 to the positive second power is 1 times 5 times 5, 5 2 times, this would be 1 divided by 5 2 times. And 1 divided by 5 is 1 over 25. Because, I'll show you real quick, 1 divided by 5, right? 1 divided by 5, divided by 5. So I'm doing this here. 1 divided by 5 is expressed as 1/5, as I just showed right here. And then if I divide that by 5, that's doing that right there. And as we usually know, that's 1/5 times. Got to do the reciprocal of the 5, which is 1/5. And that ends up being 1 over 25. So 1 divided by 5 is indeed 1 over 25. And then you can just keep on going. 5 to the negative third. I'll just do this last one is 1 divided by 5 divided by 5 divided by 5 3 times, which is 1 over 125. And hopefully you can see what's happening here. This was 125 right here, and this was 1 over 125. And I'll do this in blue. This right here, this was 25, and this was 1 over 25. And then in green here, that is 5, and this is 1/5. And then this beautiful symmetry that's happening, really there's just one of those. 5 to 0 is 1. And so that's what's happening with every single number that's a base. It doesn't matter if the base is 5 or 2 or 10 or 12 or whatever, this kind of relationship is going to happen. Now, what I could do is I could use this idea right here. Let me shimmy everything up here, and I will erase this little thing here. I don't need this or oops or this. Now, if I use this idea of 5 to the negative third is equal to 1 over 125, well, I did see that 5 to the third is equal to 125. That was up above. And we can use this idea where 5 to the negative third power, let me rewrite that, negative third power is equal to 1 over 5 to the third power. Right? So we have this relationship because 5 to the third is 125, and we have 125. So instead of 125, I can just write 5 to the third. And we have this here. And further, I can even write this 5 to the negative third over 1. Right? So what could happen here is if I place this over 1 because you can. Anything divided by 1 is itself. And if I flip this over, this goes to the bottom, this goes to the top, and as it passes through, the sign on the exponent is changing. And so that relationship is very much apparent. We can take any number we want. We can have back to the 2. If I have 2 to the 4th, what is that? That's 1, of course, right? Times 2 times 2 times 2 times 2, which is equal to 16. And 2 to the negative 4th, well, that's going to be 1 divided by 2 divided by 2 divided by 2 divided by 2, which is 1 over 16. See that relationship there? So if I have 2 to the negative 4th, that is equal to 1 over 2 to the positive 4th, right? Because if 2 to the negative 4th is 1 over 16, and 16 itself right there is 2 to the 4th, then instead of 16, I could write 2 to the 4th right there. And then we have this relationship, and further, I can expand this just to see for visualization purposes. That's over 1. So I have this relationship where if I flip this fraction over, the sign on the exponent is changing. So quite simply, the way I use this in the math problems that I work on is I will have if I have something like if I have 3 to the negative 5th power, and I'm asked to express this as a positive exponent, I'm thinking, okay, I'm going to have a fraction bar, and I'm visualizing a fraction bar. So I'm going to dot this, and I'm thinking of this. I'm thinking that 3 to the negative 5th is 3 to the negative 5th over 1, and I'm going to flip this fraction over. So 1 is going to be on top, and 3 to the 5th is going to be positive. And that's how they do it. Now, what you could see is you could see something like this. Let me move all this stuff away and move that aside. And you could see something like this. You could see something like, well, 4 to the negative second, 1 over 4 to the negative second. And what's that? Well, that would be just equal to 4 to the second power. Why is that? Well, if I have 4 to the negative second, again, I'm using that idea that if you flip the fraction over, the sign on the exponent is changing. So if I flip this over, so this goes up here and this goes down here, the sign on the exponent is changing. So 4 to the negative second becomes 4 to the positive second, and 1 goes to the bottom. And anything over 1 is just 1, so is itself, sorry, is 4 to the second power. So that's how that works out. So I'm hoping that these tutorials on exponents and negative exponents and anything to the 0 power has been helpful. Let me know in the comments what else you'd like to know. Thanks for watching.